Hello and welcome to the stream today. I've got a session for you today all about the new inlets release 0.9. This is where we've added metrics and monitoring, a new status command, a binary for Apple Silicon. So if you have your shiny new Apple M1, you can run inlets on there without Rosetta. And we've got some great demos as well. But I'm now going to bring on Engin from Schwarz. Engin, somebody that has contributed to the OpenFaz community and inlets community, to Arcade, and there's probably no place where he hasn't turned up in Cloud Native recently. So I'm going to bring him on, introduce him, and then we'll talk a bit about what we're going to cover today. So welcome, Engin.
Welcome. Thanks for inviting me. As you said, my name is Engin. I'm working for the Schwarz group. I think probably the European people in this stream already know the Schwarz group. We are behind the brands called Lidl and Kaufland. So I'm working for the IT there. And mainly I'm doing a developer advocate and also some kind of cloud enablement with the upcoming movement to the cloud from our company. So that's it.
So I know you have interest in K3S, but it seems like every week you're looking at a different technology. I can't quite keep up with it.
Yep, there are different. I mean, as you can imagine, this kind of a big company has different activities. So we have people in the virtualization team who now looking to leverage Kubernetes, for example, to say how we can provide on our internal or on our first generation infrastructure, how we can provide their Kubernetes as a service, and also all the cloud providers. So there are different activities and then different opportunities to enable the colleagues or to help them out. This is so the main thing.
Great, thank you. We'll probably hear a bit more about that as we explore the content today and look at some of your blog posts. And you may know me as Alex, the original founder of Inlets. Inlets is one of the projects I started back in 2019, and really needed a way of being able to get webhooks into an environment where ngrok was banned on the corporate VPN, the rate limits were restrictive, there was different kind of traffic like ingress controllers that we needed to expose, not just HTTP websites. And so I set about, I think it was a Christmas holiday, wrote some initial code. It was very buggy. It kind of worked. It was very exciting. And it's really gone from there. And 2 years later, it's used in production by different companies of varying sizes, and also individuals like the people tuned in today or maybe watching later, and myself and Engin. So what I did want to do is share a couple of use cases with you. Now, the best place, I guess, would be the Inlets website to look at that. This is something that I've worked on recently, iterating on this to try and get the message right. Really looking at self-hosted tunnels, and the main benefit there is that, well, you're not using a SaaS tunnel, which are incredibly convenient and very, very cheap, but you do run into some limitations around, as I said, rate limits, corporate VPNs, automation, and just what you can do with it. So you've got a simple alternative, you get secure access to whatever you're running, no firewall ports, works behind NAT, and just makes it very, very easy to use. This is a little picture of perhaps what it would look like if you've not used a tunnel before. Let's say I had an Express.js website running on my laptop. I'm actually going to show you one of those later. And it's just behind NAT, a firewall, proxy, or one of all of the above. Engin over here, on the right-hand side, he wants to access that. Unfortunately, he can't because there's just no way to get to my laptop. What we do is create a cheap cloud server, run the inlet server process. Engin talks to that. I run the client on my machine connected to the server, and then Engin can access my machine just as if it was on an EC2 instance. Now, there's a couple of ways of using inlet. Specifically, we've got this TCP mode. This is one of the most interesting ones for me. You can take SSH, you can take VNC, RDP, any kind of arbitrary TCP protocol, and say, I want that internal machine on my network, that Raspberry Pi, that Windows server, to appear on another network. Maybe an exit server on a VPN. It might be private. It might be public. It might be an ingress controller. So many different ways you can do that. We then have HTTP, which is all of your REST and websites. This is quite a common use case, actually. And what we might do is say api.example.com. That's what I want set up on my exit server. And I'm going to run something on my laptop, expose it securely, and somebody then has a URL for it. And finally, one of the other interesting ones that we've got for you is in about 3 commands, you can get a load balancer on any Kubernetes cluster, like no matter where it's running. So again, this is something that can be done in many different ways. The operator is one of the simplest ways, but it's not the only way. And there's a Helm chart and other bits and pieces you can play with too. So those are the basic use cases for inlets. If you do want to look into it more on the blog, you'll find way more detail. Specifically, we've got today's message, which is all about metrics and monitoring. So as I mentioned at the beginning, the 0.9 release adds a whole bunch of new features, and also talk a bit about why inlets would be cloud native. Engin, you've worked for a lot of cloud native projects. What kind of things do you think of when someone says this is a cloud native project?
You mean in special? I did not get this.
So if somebody said to you, I want you to take a look at this project for Schwarz, it's a cloud native project. When you land there and you look at it for the first time, what kind of things do you expect to see when something's cloud native?
That it's fully extend all the possibilities to, for example, to deploy the stuff on the specific cloud providers. This is something for me very important. So everything with this common cloud native tools, for example, with Terraform, or having a Kubernetes, a Helm chart, for example, this is very important for me. So I can embed it an ecosystem, an already established ecosystem, into my way of working without changing too much, for example. So if I already have, for example, my Helm charts in place, I just can drop into my Argo CD, for example, the inlets operator via the Helm chart, and then I'm good to go. So this is for me very important. And of course, going to all extent what the specific cloud provider, for example, offers. So if they have some kind of firewall natively or some kind of load balancing with their building blocks, everything is in place. So, and this is, for example, in inlets, I saw this, and maybe we talk later about why I'm so amazed of inlets. So that's
So Alexis Richardson is a friend of mine, CEO of Weaveworks. Used to be the chair of the TOC at the CNCF. He gave a presentation a little while ago now, 2017. He said automation, lots of it, a real focus on the application rather than the infrastructure, maybe using containers, and helping people to understand new patterns for logging, monitoring, reliability, microservices. So we're seeing that definition change a little bit. But inlets was really a blank slate for me. And so I was able to create that as something that fitted in well with other cloud native projects. And I'd had that experience through OpenFast. So you can read a bit more about that in the post. We've got a few different environment variables and flags for you. Now, this came from working with Nathan Peck at AWS. Thank you, Nathan, if you're watching this live or later on. He needed to wanted to deploy inlets for ECS anywhere. It turned out that when you're running containers on a Raspberry Pi using a traditional VPN, interrupts the CPU, makes the whole system go really slow, isn't ideal. And so he was interested in inlets as a lightweight alternative to VPC peering. But in Fargate and ECS, they tend to configure things through environment variables instead of through files or flags. And so we've added token env and license env to both the client and server where it makes sense. I can see Johan is in the comments as well. He wrote a blog post about fly.io to host your exit server for free there. Host 3 of them actually. And we added token env to the client back then. So now we've put that in the server. and license them is there as well. The inlets file server, the built-in Dropbox, if you like, that's now moved from HTTP file server up one level. Token from is going to be renamed to token file because it just makes more sense. You can use both for now, but one of them will go away, i.e. This one. And when it's gone, it's gone. So just be prepared for that. Maybe move over. We used to have a print token flag. I don't think it did anything useful, so that's actually fully gone. But one thing I'm really excited about is the status command. What this allows you to do is see for a TCP or HTTP tunnel, how many clients are connected, when they last connected, how long they've been up for, what sites they're exposing there. Johan and a few other people here were quite helpful in sort of giving me some feedback on how this should look, and Nathan as well. And then when it comes to the HTTP tunnels, you can see the various host names and what service they go to. So you can use one tunnel or one client to expose multiple endpoints, which is quite neat. One command works with both kinds of servers, but it will only work with 0.9 and forward. Have you had a chance to try that yet, Engin?
No, I did not try this feature. I'm more focused on the monitoring part, so that was the thing.
Yeah,
I put energy into it.
Okay, that's fine. Anybody in the comments had a go with this yet? We'll get a chance to. Effectively, we can use curl, or we can use a normal inlets client. If you use curl, that means you can then integrate this into your system. You could parse the JSON that would come back. You could detect when a tunnel is no longer needed, do all kinds of cool automation with it. And I guess this is probably a good time to ask you, Engin, what is it that really interests you about inlets to the point where you want to contribute to it?
That's a good question, because I like the flexibility. I mean, you have several ways on how to build, for example, the exit server. We have the inlet scuttle. I don't know, Alex, if you go later with a link or something like this. So you have a CLI where you can easily choose which provider you want to use. So I know out there people have some preferences. One people say, I'm a DigitalOcean fan, I go to Linode, and I'm a German, I like Hetzner, for example. That's all. Everybody has their own choice. And with inlet scuttle, for example, you can choose easily with the CLI. So if your workflow will be with CLI, go with the CLI. But if you say I want to use it in a Kubernetes way, I can use the operator. And then comes me, for example, who's always on the chase to try new cloud providers. So for example, I digged through Oracle cloud infrastructure, and I had the opportunity to use Terraform and the binary of inlets, for example, to build my own exit server on the Oracle cloud. So that was really nice for me. So I really like building new stuff from existing binaries and tools, and say, look what you can do now. And that was one of the things I'm so amazed of this. And
so I think with the Oracle example, and I like the pictures here, agents everywhere. You actually managed to do everything. If I find it at the bottom through, was it Cloud Init? Find your example. You, rather than having to update the inlet CTL or inlets operator, you actually just have a Terraform template, which again shows how versatile it can be to just have a binary that you can use however you want. And you install and set it all up. Is that correct?
Yeah. I just, for example, use the cloud init approach. I choose there to go with Ubuntu with the lowest machine that's possible. I have even the opportunity to use an ARM machine, and then I just use the cloud init. That's something everybody knows. I mean, I expect that everybody who's using this in the cloud world knows, for example, how to provision automatically with the cloud init, and then you can just put the binary inside, and boom, your exit node is ready to use. And with Terraform output, you can even build your own string to copy paste stuff, what is really nice.
Like a connection string, for instance, at the end.
Yeah.
Now, I actually think this is the one that I meant to pull up. So this was your first one looking at OCI. What's special about OCI?
I mean, as I said at the beginning, I want to try different stuff. So at the moment, I'm really behind, for example, behind Yandex Cloud to get access to Yandex Cloud because I really want to get my fingers on a Russian cloud provider. But here, for example, the Oracle Cloud infrastructure, they have really nice features I didn't know before. So I had to dig into it to find out that they, for example, offer free forever servers as you register after you use your free credits, cloud credits. You are good to go with 2 machines for free. For example, you can get one Intel architecture and you get an ARM architecture with it's called a flex server, where you can go from 1 core up to 8 GB of RAM, and this for free. For example, that's absolutely perfect for inlets, for example. So I can quickly spawn it, and then I can use it without additional costs, and that's a big thing for me.
I sent a message into the comments to ask, what cloud are you using when you're using inlets? And I guess what you've shown us here is that you don't have to stick to the ones that we've added support for in automation tools. You can just set one up manually, or do it even better, use Terraform. And I like that they've got that free tier. That's definitely fun. Okay.
On top, for me, for example, as a corporate guy from an enterprise environment, I can even take this approach to my on-premise infrastructure. So nobody says it's not possible to go, for example, to my vSphere providers, to the virtualization folks in the company, and say, hey, can we get, for example, a Proton server from vSphere and put, for example, the binary in there? So everything is possible here. So that's really nice and flexible.
Yeah, I like that. I like the approach that you've taken there. So if that's your Oracle blog post, we then have one that's kind of a spin on that, which is where you added the monitoring and the Grafana cloud. I guess we're going to have a look and run through that demo later on. Yep. So that looked like quite a lot of work. How long did it take you to put all that together?
The good thing is, for example, the Oracle Cloud, as I said, these are different building things like a Lego. So I already spent some time with the Oracle Cloud because I found it also quite interesting, the whole monitoring as a service approach, to say, is this feasible, for example? And then I just put all the building blocks together and say, okay, now let us mesh up something new. And then we have Terraform, we have inlet, and soon we get also Oracle Cloud to it. Just drop in the cloud in it, the stuff we already know, the Oracle agent. They have a special slim down agent, and you're good to go again. That's the amazing thing. Yeah,
definitely good. One of the things I wanted to update people on is that if you've not been around for a while, may be news to you because it's only been around for literally just shy of a month today, which is inlets now available on a subscription, on a monthly subscription. So rather than paying upfront for a yearly license, you can just get it month by month. If you want to try it out, you can set it up for a month. When you come to the end of the month, you can cancel it if you don't think you're going to use it, or you can carry on a monthly basis or convert to yearly, and there's a bit of a saving for doing on a yearly basis. Also go through some of the differences versus ngrok, which again is a great tool. I mean, I used to use that until I ran into some of the limitations with it. And it's very popular still. But this article really just explains some of the differences, what it really is, and also kind of touches on Argo tunnels a little bit as well, and what you can expect. We then have also like an opportunity to contribute. So Johan and Engin, inlets, the core of it is a product that's closed source, and what we have is almost like what you could call a closed core open crust. So the tooling, the Helm charts, the documentation, tutorials, automations, all open source. You can do what you want with it. But then the core part of it, you get a license for it, and if you're an individual, pick the right tier, plug in your home lab, your Kubernetes cluster, or your laptop, or whatever it is. So that is one of the changes that people may not be aware of. So rather than going for a year in advance, you now have that option. And one of the people that's actually gone and done that is a guy called Zespray. I hope I'm saying that right, in Taiwan. and he asked me a question. He said, do you have an Apple Silicon binary for inlets? I said, I don't, but I'll figure it out. And if you buy it, if you become a customer, I'll add it. He became a customer. And about 2 weeks later, we released the release candidate where he now has that. And so Zespro's written basically a bit of a tour of inlets. He gives you an idea of what it looks like, all the different tools you can use with it. But he also has a couple of really nice use cases and diagrams. This one, he shows how he's got his Windows server running RDP. He's able to make that available from the office on his computer, where he can then access that when he's away from the office using the TCP functionality. He also shows you the HTTP mode that I mentioned earlier and that built-in file server. The file server basically, I don't know if you've used it, Engin, is a much better version of the built-in Python file server. It can effectively put a password on itself. It can allow browsing or not. So like when you share a Google Doc and you say anyone with the link, that kind of behavior. And a bunch of other things like that. So why would you use that instead of Dropbox? Well, if you have, I don't know, a 2 gig file to share, an ISO image, or even a backup of your blog, you can run this, share a secret or password protected URL, and then immediately download it without waiting for it to get uploaded, because it's a tunnel. And you don't really have to worry about the bandwidth limits. If you use a VPS, you get about 2 terabytes of transfer per month per VM on most clouds. Do check the small print on your specific cloud, but that's pretty generous, and there's no waiting around anymore. You can go and have a look at his blog post. I will share a link to all of the show notes. And he also shows how he uses Kubernetes, and he uses that along with Metal LB. Now, Metal LB normally just gives you load balancers for private services on your own network. Maybe gives them an IP from your LAN. If you combine Nginx, if you combine Metal LB with inlets, you can have the best of both worlds. So you have your private LAN IP addresses, and then maybe for your ingress controller, like traffic, you can then have that IP address and that accessibility. So I was really impressed with this. I thought it was very comprehensive. I don't know if you've had a chance to look at it, Engin, maybe you want to check out later. Okay, well, I think we're getting through most of the notes that we have. What I want to show people is the release. Now, this is technically a release candidate. Why is that? Well, it's pretty much good to go, but I would like to see some of the community. I know we have a few people tuned in now. Try it out. Engin's been trying it out. Nathan Peck's been trying it out. I've been doing various things. I'm going to show you it in a second. But I'd just like us to sort of kick the tires with it, see if we can break it, see if it all makes sense. If there's something that you don't like, or something that you do like, either way, let us know. Appreciate your feedback. Okay, so I guess what would make sense now is if I give a quick demo of everything running on my machine. And what I would do, okay, got a comment from Johan. He mostly uses GCP and DigitalOcean. I know that a couple of the Cert Manager team, when they use inlets for testing Cert Manager, they use GCP as well. I know that because they raised an issue once, and Johan helped us fix it. So let's get my whole screen. And hopefully this will be big enough. So I have a lot of windows from earlier where I had everything all set up, ready for today. Let's get that down. And we want so these are the show notes I'm going to be showing you later. I'll be able to open Grafana. What I'm going to do is run a client on my computer and a server on my Intel NUC. So this is going to be my client command. And in fact, we could probably make this a bit better if I use tmux. So we'll put our first command in here, and then we can split our screen down. I'll log into my server. Over on the server, I'm going to run inlets pro server command. What do you need here? Well, we need to decide if it's a TCP tunnel or HTTP. For what we're doing today, the HTTP one probably makes sense. So I'm going to run that with a token. That is the password for the control plane. I'm then going to jump up to my top screen. I'm going to run the client. Now the client's saying connect to that machine on my network and then expose or allow over the tunnel port 8000, right? And token test1 is the password. Previously, this used to say connecting to proxy, and that was the last message that you got. It now, thanks to a few suggestions from the community, says connection established, so that you're going to get some feedback that it's not just trying to connect, it's actually successfully connected. But when you got a few messages, what I'm going to do is close down what I had earlier. And we'll start our process, our local process. So what I have is a Node.js website. And it was Express.js Kates. We're not going to run it on Kates. I'm going to run it locally. You can see it's just a very simple HTTP server. And if we look at the routes that we've got, one of them returns a JSON array. The other one returns a simple HTML file. Just like the example on the blog, right? So if I go to localhost 8000, we've got it there, and we can get the API as well, just on my loopback. What I want is to access that on my server instead. Now, this server's on my local network, but we could imagine that it was on DigitalOcean or GCP like Johan is using. So what do we do? Well, we've got the server running there. It will listen on port 8000 by default in HTTP mode. You can change that. It also has Let's Encrypt capabilities. The client is saying this is where calls need to go. If you've got a DNS name for this or multiple services to expose, you can do that too. You can just add them in here. Okay. So theoretically, I should be able to call this IP address on port 8000 because the tunnel is up, and there we are. We've got the API response back, HTML response back. If we call /links, we've got the links response back from the API. It looks like that is actually running on that server. It's not running on there. What is running on there is the inlets tunnel server. Okay, so that's our basic scenario. And then I'm going to show you how we can start monitoring this. First of all, let's try the status command. So very similar to the command above. We've got the URL, and then we've got the password. And here we go. We've got inlet server status. We've got the process uptime, which could be the same as the server uptime. You know, it could be, it could have restarted, in which case you'll get an idea of the difference there. The host name of it, we've got the version of the code running, the client ID, which is the ID up here that you'll see as well. And the ID will also be printed out potentially in the server at some times. What else have we got? We've got the remote address, so we can potentially tell where that connection is coming from. So if I ran this on DigitalOcean, ran the status command, this would be my home IP address that I've got selected. It's been connected for 2 minutes, and those are the upstreams. Right. So if I was to go into the top, cancel that, run it again, we see no clients connected. Then we restart the process, and now we see we've been up for 4 minutes, connected for 1 second. So that just helps you understand how healthy your server is, what tunnels are connected, what they're exposing. And yeah, you can actually have, and I know Johan has done this in the past, Prometheus from my Raspberry Pi, OpenFAS from my Intel server, something else, all different domains, all exposed on the same server, just with different host names, right? And that's how they would be routed to the different clients. Each client has its own ID, and this is exactly the same for the TCP mode as well. Right, so that's in place. We don't really need to see this screen anymore. So we'll go over to the next one. There's our local server running. That hasn't got any Prometheus metrics built into it. But because of the new functionality, you can actually get metrics very easily. If we look at the Prometheus configuration I have, Prometheus always scrapes itself. That gives you some basic data on how many Go routines are being used, etc. But then I've got a job for my tunnel, and it's going to the same path as the status command /metrics. This is a target. I'm running Prometheus on my machine. I'm not running it in a container. So I've just put the IP address of the NUC server. We then have a bearer token with the credentials, which is what we put in the client command and the server command. And we can run this with this command, -config file. That will then run on my local machine, and I can open it on 9090. First thing I do, I don't know about you, Engin, is I go and click on targets, because that tells me whether what I've wanted to scrape is working or not. Actually, we can see that the metrics endpoint was called on that tunnel. Who called it? Well, it was Prometheus. It just called it again. And we'll see that actually that's probably getting called every few seconds. I think it was about every 15 seconds last time I looked. There we go. So every 15 seconds it's getting called. All the metrics are being pulled in. And then you'll see these in the blog post, all explained in detail. But we can see them here. The control plane, how many clients are connected right now? Just the one. If we were to control C this, that would go to 0. We can also see how many connection requests we've had, successful or otherwise, because remember I control C this and I came back to it. So we've had 2 on there. We can see the metrics endpoint is being called 7 times. I ran the status command 3 times, and then you can use this data to graph or understand how your server is being used, how reliable your endpoints are. And then this is the one that I think could be quite useful. By looking in this metric, we can see that my microservice has had 2 HTTP gets, and both of them gave a 200 back. Now, I don't know what will happen if I do a post, but we can try it. The post seems to return 200. But if we try a URL that's invalid, that gives it 200 as well. Not quite what I was hoping for, but if you had something that would give an error or it would be unauthorized, then all of those metrics would show up in your Prometheus. And then you can also go and write a GraphQL query, a PromQL query, and get a rate of these invocations over a certain period of time, which probably brings us on to the next part. Once you've got these raw bits of data and you're pulling from one or more tunnels, what do you do next? Well, really, you don't want to be looking at Prometheus. You probably want to be looking at Grafana. So I've downloaded the Grafana server earlier. Engin's, you're going to show us this with a SaaS version of all these tools, aren't you?
Yeah.
Yeah. Now, this is a dashboard as I had it running earlier. I'm going to do a refresh and we'll see different data. But you could see the metrics invocations are very steady. tick, 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 tick. And that's that 15-second scrape from Prometheus. We then have the connect URL, which was path done 3 times. And then HTTP traffic over the last minute. So if I refresh this, that data will be very different, right? We almost have it at 0 because we don't really have enough data to see something interesting. So what I've got is Hey, which is a traffic generation tool written in Go. Also use this for testing OpenFAS, auto-scaling. What I'm going to say is I want 10 concurrent connections for a length of period of 30 seconds. It can go as fast as it wants within that time. And I'm going to put that against the server's data plane. The data plane is, I'll show you. Basically, then going to go to the Node.js website. So then we won't necessarily see this live because it's only going to update every 15 seconds. We see the data, and this rate, if we edit it, we'll see is using that request that I showed you, going over the 1 minute window. Now we can also put in there if we want code of 200s, so we could filter out errors. We could invert that and filter out success. It's probably more interesting to monitor errors than things going well. And let's refresh it. That is now finished because I don't see any more traffic. And if we look over on Hey, which is this window, you can see we did quite a lot of requests there, 142,000 requests. You get an idea of the latency distribution of this. Reasonably quick for everything running on my machine and that Intel NUC behind me. No errors, which is what we want, and no particularly slow requests there either. Now, Engin, did you develop your own dashboard for your example?
I did not. I was not sure to create one because that's what I asked you during. What I also suggest to go to the Slack channel to get in contact with Alex. I also asked to say, does it make sense to ask the community or to make a contribution dashboard you can upload to Grafana, for example, because that's for me always the first place. I also look for a finished dashboard, so I have a good feeling what the persons who created the tool would monitor and say, hey, this could be very important for you.
That makes sense.
Yeah.
So I'd like to have a dashboard on there. Maybe it will look like the one I just showed you. In the blog post on the 09 release, it talks about the names. So depending on what type of tunnel it is, it's a slightly different prefix. The HTTP tunnels collect what is called rate error duration, or RED metrics. You might be familiar with that term if you're in the Prometheus community. So again, we can also look at the duration of these requests that are going through the tunnel. And I didn't have to add metrics to this Node.js microservice. I got them for free by using an inlets tunnel. So again, that could be useful to you separately. When it comes to the TCP side of things, we don't really know whether there's HTTP, SSH, or goodness knows whatever else going over that. So instead, we show you the connections that have been made and the gauge of how many are open right now. So if you had an SSH service exposed, 10 people were connected to it. Right now, the gauge will be 10. The connections total will be 10. If they all disconnected, the gauge will be 0. The total is still 10 for that time window. Hopefully that makes sense. Same if it was, I don't know, traffic that you're exposing. If you had 100 users connected, you'd see this at 100, this at 100. If you'd had 1,000 in the day and then nobody was connected, the total would be 1,000. Something that not everybody knows is that you can actually generate a systemd unit file for any of the inlets commands, client and server. That could be useful here where I'm actually running, as you can see in Tmux, both parts of that. Well, I could set them up in systemd. I'm on a Linux machine. I could then have it running in the background, get logs from it, etc. So really, these are the only two commands that you need to set up a basic client and server. Plus, you could use the file server or my Node.js example. And then a basic Prometheus example. Rather than there being no authentication for scraping, it's the same token that you're using for the server. And that's basically it. So in this tutorial, you can run through, and even if you've not used Prometheus before, in about 10 minutes, you'll have it all up and running on your local machine. No Kubernetes needed, no Docker needed. You can explore the values, get a real sense of how it all works. And in my example there, I had a 404, right? So that, I think, was an open fast function. And that, I guess, is most of what we've got to show you. And we'll have Engin's demo as well. The other note I wanted to mention was that the TCP mode now does load balancing, and it didn't before. What does that mean? Well, if you've got two K3s nodes and they're both running traffic, you have an ingress record that exposes Grafana, let's say, on the internet through an exit server, you can now have HA in the TCP mode. Right? There's HA already in the HTTP mode, but it wasn't in TCP. Now it is. So if you're using an inlets operator, using the tutorial with traffic, or using the Helm chart, you can get two tunnels, TCP tunnels, running on two different nodes, both of them connected to the same server. That server will make that available. If the first node goes down, the pod on the second node won't have to wait to be rescheduled. It's still running connected, and you won't lose any traffic. You can also make the server HA. This is something that Nathan was asking me about, by running two instances of it, right? Or running two instances and using a load balancer IP address or a floating IP in front of it. And like Engin said, there's so many ways that you can do this stuff. So I guess we now go over to you, Engin, and see what you can show us with Oracle Cloud and your demo.
Yeah, I just wanted to add to your demonstration that the monitoring and measurement is one part. What I like also is now I have also the opportunity to get some alerting onto it. So if inlets becomes a crucial part because you do some fancy multi-cloud connections or whatever, it's also important to know when, for example, the exit server goes down. So I like this approach also. So it opens us more possibilities, and we can use our established way using the alert manager and sending it to Ops Genie, whatever system you have established in your company or in your private part, usage. So that's completely up to you. So that's my first time in this sharing in this.
That's okay. If you want to get it ready,
yeah,
we've got a couple of questions. So while you get that ready, Furkan has said hi from Turkey. Hi. We've also got another Johan, and his question is, he's considering inlets to substitute another service he uses where all the devices are on the same overlay using WireGuard. Would he need a tunnel per service or per server? Really depends on what you're doing. What you might find is something like WireGuard is great for saying, I want effectively a corporate VPN, but my own one, where everything on the network can access everything else and all the hosts act like they're all together playing happy families. That might be your best solution if that's what you need. However, if you have, I don't know, two servers that you want to RDP into, inlets could be a very quick way of doing that without exposing your entire network or having to set up complex ACLs or managing IPCDA rules or rotating public key tokens or relying on a SAS. So it really depends. But if you're interested in knowing more, you can drop into the OpenFast Slack, into the inlets channel. We're happy to chat with you, see if it's a good fit for what you're doing. Now, if you want to bring your screen onto the page you want to share, I'll put you on.
Yep, I shared the whole screen, so I
can see
all
the video.
Yeah, I will move this away.
Down. Yeah, just minimize that.
Okay, you let me know when.
There we go. Yeah, you're live now.
Okay, so just go quickly through the code setup, and then we can go also some details. So what I did for the OCI is I just created some basic Terraform script where I say, okay, let us build the infrastructure I'm going to use with the Oracle cloud infrastructure. So creating a password generator, saying, okay, which kind of machine I want to use. Here, for example, I choose the shape. They call it shape. I mean, there are different names for the actual instances behind this. So what is it? It's here, for example, it's a one CPU machine. So the lowest you can get, and also the one who's free. And then you go to the details and say, okay, I want to use Ubuntu image and so on. So I collect all the data from the existing library, for example, the image library they have, or the shape library, and then start to build my my VCN, the subnet. I mean, this is all stuff you know in some terms from other providers, so no big changes here. The only thing you have to keep in mind, for example, with Oracle, is they're quite strict in the way they handle, for example, the whole security stuff. So per se, everything is closed, and you have to open it one by one. So, for example, here, opening the 22 port, so I can SSH into the stuff to see what's going on. I mean, it's not necessary, but that's fine. Here's the port of the inlets, for example, and because I'm quite lazy, at the end, I just open everything because I say, okay, here in the demo case, I did not want to bother with going now to redeploy everything. But as Alex showed already, you can say, okay, the 8000, for example, for the HTTP, this is the default one. I'm not going to change this. So you could easily enter here the min max and say 8000. So that's also fine. And you can.
I think if folks are familiar enough with Terraform to play with this, they should hopefully understand broadly what's happening there.
Yeah.
That looks good.
Yeah, that's the good part. At the end, I generate my connection string to say, okay, I'm also lazy on this one, so please show me the connection string. I already deployed the stuff, so I can see, for example, I can see, okay, I decided with the variable I want to create an HTTP client. So there are different parameters per you can change this. So here, for example, I know in HTTP port and upstream are all together. So I just create the stuff here with one thing. If I create a TCP, I can add also an additional flag with several ports, for example. So here, everything is generated, and it's good to go. And,
very nice. I like that, the way you can sort of gather the data. There's a specific word for it in Ansible, wasn't there, for all the bits of data, bring them together and get a connection string. Perfect, just like what inletctl does.
Yeah, that's the. I mean, actually, you're mocking for you're extending inlet scuttle without extending it. So that's really a cool stuff. And then here I just can create now the port, as Alex already showed. I don't go into details now. It's here. Started, the connection is established, and what I did is I created an Engin, and I should see now. Yeah, I see now the Engin welcome page, so that's completely fine. But this is only one part. So the most interesting part is now
where's the Engin? Where's the Engin running?
I run it as a container. So
okay,
if
so
I go
did a Docker
here,
run?
Yeah, it's my Docker engine, just to have something to play around. It could be anything. And
here's something that I've seen Johan do, Siebens, is you can actually run the inlets client as a container and talk to it through the container network. And he's got a couple of nice examples with Docker Compose. So you could Docker Compose up your Nginx or your blog plus the inlets client, have it all together. Which might be something to try in the future.
Yeah, that's absolutely. That's also a nice approach.
Should we share the IP address that you have, see if somebody wants to try and hit it?
Yes, of course. Did you copy it?
130, 61, 205, 65. Is that right?
Yeah.
Can you give it a quick shot on my end? Now, you haven't got logs enabled in the container, so you probably don't know if you'll see this, but I'll try it.
Yes. So that's one part. So nothing changed here, what Alex showed already, but now comes the interesting part to say, okay, how I can use, for example, the Grafana SAS solution to monitor the stuff. I have the problem, I don't know with how your machine is spec'd, Alex, but if I start several things, the machine gets quite loud. It's an Apple, it's still an Intel architecture, so I get the fan going up and it's quite annoying. So I try to reduce additional stuff on my side. On top of it, I don't want to run several containers and keep juggling with the configs and so on. So I looked around and say, okay, how I can leverage what is outside there to use. So with the Grafana part, I only extended the cloud init script, for example, here, and say, okay, download please the agent for me in the version blah, and start the agent. I also created here what Alex showed, also the basic Grafana, here in this case, the agent config. So here, this is something you see familiar from Alex. I shamelessly stole it from his article. So this is one-on-one Prometheus YAML for the config. And as you can see, here comes additional stuff. One important thing for the Grafana SAS solution is you remote write everything. So it's a push approach. So when
does that mean there is no Prometheus?
No, it's a slimmed down version. It's their own version. The base, it's a Grafana, it's a Prometheus, and they again confirmed this in Twitter when person asked about this. And the only difference here is, for example, you push the metrics. So when that's the only thing.
That sounds interesting for Edge and Raspberry Pi. Like I might want that for just monitoring in general and use it with my own hosted. I don't know if it work. Will that work with my own hosted Grafana?
There's also the remote write is, for example, for Thanos and for Cortex and so on. These are the stuffs where you can use the remote write. For the local Prometheus, please, maybe I'm wrong and so on. You have the federation approach where you go to the federation endpoint and then you can also gather the stuff from there, but it could possibly also change. Okay. After you created an account with your GitHub account, it's quite easy. You can choose between different different methods to create an account. I choose the GitHub one because I have already a GitHub account. You have full access in this free tier to this different products of Grafana, and I'm sure everybody knows some of them. I mean, Grafana Prometheus are the big ones. You have the alert manager, Loki, that's quite nice for the whole logging stuff, and then also Tempo for the whole Jaeger-like tracing stuff. So that's really, really cool. I just focus on Grafana and Prometheus. Once again, I'm not working for them, so I'm not trying to promote or whatever.
I don't think anybody would think that. The amount of different projects and products you look at, there's no way you could be.
Yeah.
Okay.
So that's, but I mean, nothing is wrong with this, but I'm sure that people say, hey, I'm more a Datadog guy and so on, or Instana and so on. So nothing wrong on this.
Nathan was one of those people. He mentioned that he would like to use Datadog, and I can ask the community about it. I'm more comfortable with Prometheus, but there is an adapter, so there should be something for everyone.
So here in the Prometheus, to set this thing up, so you go into the details of, and then everything is written. Where is the endpoint? So here's the remote write endpoint. This is stuff you're going to enter or put as a variable in your Terraform or whatever approach you're going to take. This is the so-called user ID. That's something I also was quite a problem. I thought it's my user ID, so I entered DVN. No, it was just this number, and then
that API key. You don't want to share that, so if you can avoid it.
Yeah, I don't. That's something here.
Good.
Okay, so that's one part, and then the other one, what is the more interesting, or what is also interesting, is the Grafana part. So when you click on Grafana, you come in your hosted Grafana, and then you can start to work on. And you have here, for example, the several integration methods. Where is it? Here you have the integration management. You can choose, as you see from Caddy, everybody knows this, to different
have you got a test dashboard yet?
Yeah. So I went for the explore method. So in this case, let us go choose our source, and then we can go to HTTP, and then we go to the what you already explained, the connected one, and then we can see.
Look at the is this a HTTP tunnel? Let's look at the requests. Are you seeing them?
Yeah. So HTTP request total. And then we go here, and there's much going on at the moment. So it's the metrics endpoint what gets scraped here.
Some of those were from me when I shared the IP.
Yeah. So there's something. Let us see the last 30 minutes and the last hour. So they're coming stuff in.
And that's just looking at that on its own, but we'd probably more likely look at the rate of it. And then, as I said before, maybe look at specifics. This is the control plane itself.
Yeah.
Oh, look at that. You have a 401. I wonder what happened there. So somebody tried to get your metrics endpoint with an incorrect authentication.
That could be me, because I tried it before and I did not send the token. So
that could be it. And this is another thing that you can now understand better that you couldn't before. Is somebody trying to abuse my tunnel? Somebody trying to connect? Have I got one of my clients with the wrong password that needs updating and it keeps asking to connect with a wrong password?
Yeah, so that's it. And let us see if I can run oh no, it's not. He's no complaining. I thought about maybe I can run a siege, or you did it with Hey.
I used Hey. You should be able to use whatever you want.
I should use 8,000. So yeah, now I use the siege, and I should see some changes here in my endpoint. I put the scraping interval to 1 minute, because I was I was like, okay, 60 seconds, it's fine for me. That's something perfect for me. But you can play around and say, okay, what is...
so does anybody have any other questions for us on anything we talked about, or anything relating to inlets? Let's see your data. It's probably not refreshed yet, has it?
Yeah, it takes some seconds to appear here. So, but that's it. I mean, it's not rocket science, and it does what is meant to do. And as you can see, I don't need to juggle with Grafana, Prometheus, and so on. I just connected it, and it's working fine.
I'm looking forward to seeing that graph go up in a second. We've probably just caught that right at the end of a scrape. And this is something that's configurable as well, isn't it? So if anybody wants to try it out, you don't have to run Grafana yourself. But when I did it and showed you, you just downloaded the binary, ran the process.
Yeah.
I have a Linux desktop, which I find to be quite efficient for developing code, running these sorts of things. But it will be in there. Great. All right. Well, Engin, what is next for you with inlets? If I just take your screen off now.
Yeah.
What are you thinking of contributing, or what kind of things are you interested in seeing in the roadmap?
I mean, what I'm quite interested at the moment, that you see also with my pull requests, for example, is to get the whole cloud provider stack working continuously on it. So we saw, for example, one of the community members said, hey, on my Linode, when I shut down, for example, the exit node, there is some funny investigate in this part and say, okay, how we can make the experience better, how we can continuously improve the providers, because the cloud providers, they keep on changing their stuff too. So this is something I really like to participate. And of course, my biggest dream is, as I said at the beginning, to finally get Yandex on board. And I'm really in big discussion with them. I know some of the persons there now, and they promised me next month they're going to be open also for private, non-Russian, non-legal entities. And they promised me that I can connect first, and I want to bring inlets also, for example, for all the Russian users, to say, okay, they are used. I heard, I'm not a Russian, so I heard from colleagues here in Germany that Yandex is the Google of Russia, and everybody is on Yandex. So I think it would really be nice to say, okay, make it sense either as a Terraform with the OCI to provide this, or asking you.
I think the Terraform would be a great way of doing it, like you did with Oracle Cloud. We've not gone and added Oracle Cloud to inlet CTL and the operator, but you can always just run the server yourself, or use Terraform or Ansible, whatever you're comfortable with, If you're even into that kind of tooling. I mean, some people are happy just to go and click a button in a UI, and that's fine as well if that's what people want to do. So yeah, the monthly subscription is now almost a month old, getting more people joining that, which is great. And a couple of companies have decided to use a subscription as well. Let me know what you think is missing if you're using Inlets, or what's frustrating you. There's still some work ongoing around Inlets Cloud, which is not a SaaS, but a kind of hosted version, give you a bit more visibility into what's happening, how many tunnels are connected in a visual way, some collaboration with your team. So again, if that's useful to you, let me know. Maybe I can get you set up to run with that. So we're coming to the end of our hour now. Engin, thanks for that demo. I know you worked really hard on that blog post. If people want to try it, where's the best place for them to go?
Just to show the people that everything is working, I just quickly share the Grafana screen. So maybe you can switch to the screen.
If somebody wanted to try your blog post, where should they
go? Just go to my GitHub account, and then there's the code, and then you can work on it. You can fork it. You can do whatever you want with it, or give some feedback and extend it. So at the moment, the master branch is for the release candidate. As soon as the release candidate goes really to GA, I'm going to change this also, and then you can start if you are interested.
Derian.
Derian. That's it.
Genau. Yes, we've gone over to German now. So there you go. If you want to connect with Diri, head over to there. Also shared the OpenFast Slack earlier. It'd be great to have you there. If you're using Inlets or thinking of using it, if you're watching live or tuning in later on, more the merrier. We'd love to have you there. Happy to answer questions and help you get what you want to get out of Inlets. So there will be another session next week. I'm going to be meeting with Mark Coleman. We're talking all about developer marketing on the channel. Love to have you there. Subscribe, like it, thumbs up, share it with a friend. It'd be great to have your support. Okay. Right. Well, I guess it's time for us to sign off and have our dinner. Thanks for coming.
Okay. Cheers. Thanks. Bye.
Right. We'll see you next week.